Alright everyone, welcome to a video on solving one-step inequalities. So the nice thing about these is that it's almost essentially just like solving equations, except that we're having this inequality symbol there, so we're now going to have to draw a number line showing where all the answers could possibly be. So just to go over again our inequality symbols, we have our less than symbol, which when we graph gives us an open dot. We have our greater than symbol, which gives us an open dot. We have our less than or equal to symbol, which gives us a closed dot. And then we have our greater than or equal to symbol, which also gives us a closed dot. Now, that equal to is what makes that dot closed. It says that, hey, this is an answer. That's possible. Here, when it's an open dot, it means that the number that you're starting on is not an answer. So addition, subtraction solving is very straightforward, very similar to what we've done in the past. So let's go ahead and jump right in with that. So our first example says we have x minus 2 is less than 4. So just like our equations, we're just going to solve it. We're going to pretend like it's an equal sign, and we're going to solve it. So we need to move minus 2 by adding 2. So we add 2 to both sides because we still want to get that 0 on the left, and then on the right we get 6. So we wind up with this x is less than 6. Now we're going to graph. So now we're going to graph. So we put the 6 in the middle. Then we're going to go a little less, and then a little more. And it's going to be an open dot. And since it's less than, our arrow is going to point less than 6. So we get our number line. 6 is in the middle. 7, 5, open dot. Our arrow goes less than 6. So that's straightforward. That's the simplest that they're going to look. We're going to do another example here where we have to do something a little different. So this is a little different than what we just did. The x is on the right instead of the left. Now with inequalities, that makes a big difference. You always have to have the inequality on the left. Now we'll just wait and do that at the end because it's a lot easier when you just do it at the end as opposed to just at the beginning, because there could be all sorts of things going on at the beginning you don't want to mess up. So we're just going to get this x by itself. So we are going to move plus 3 by subtracting 3. So we're going to subtract 3 to both sides, just like we normally would. 8 minus 3 gives us 5. 3 minus 3 gives us 0. So we get 5 less than or equal to x. Now, we cannot graph it here. This is not a complete statement. Saying 5 is less than or equal to x does not make sense. We do not know what x is, so we cannot say 5 is less than something that we do not know. So we have to flip. So we are going to flip everything. So our less than or equal to symbol becomes a greater than or equal to. So x flips, 5 flips, greater than or equal to. Now we can graph. So we graph 5 in the middle. This is a closed dot. And since it's greater than, arrow's going that way. So this was because it's less. This is because it's greater. Five, 6, 4, closed dot, greater than. That's it. Okay, so whenever we start solving with multiplication division, we have some other things that come into play. So multiply and divide, extra rule. When, it got all funky, didn't it? When you multiply or divide by a negative, flip the inequality symbol. We're not going to flip the whole inequality, we're just going to flip that symbol. And we'll go ahead and start right off with an example with that. So we've got y divided by negative 2 is greater than or equal to 3. So we need to move our divide by negative 2 by multiplying by negative 2 to both sides. So times negative 2 times negative 2. Divide by negative 2 times negative 2 equals 1, which is what we want. And 3 times negative 2 equals negative 6. And dividing by a negative flips our greater than or equal to into a less than or equal to. So our y comes down. Negative 2 is gone. This flips, and we get negative 6. Now we can just do our graph. So now we're going to graph. It is a closed dot. Arrow going that way because less. Negative 6 in the middle, negative 7, negative 5, closed dot, arrow going less. And then for our final example, we will do 16 is strictly less than 4x. So I'm not going to do a negative thing on you here. And this will be the most common thing to end with whenever we go with our multi-step inequalities, just like with our multi-step equations. Dividing is that thing you're going to do 90% of the time, it seems like. 99% of the time, it seems like. That's what I meant to say, to finish off an equation. So we have to move our times 4 by dividing 4. So we're going to divide both sides by 4. 16 divided by 4 equals 4. 4 divided by 4 equals 1, which is what we want, since we want a 1x. So we get 4 is less than 1x. Again, we just don't write the 1. We have to have the x on the left, so we flip the inequality. So x is on the left. So that means my less than turns into a, so it becomes a greater than. So x is on the left, greater than 4. Now we can graph, open dot, and then because it's greater, it's going to go towards the greater numbers. So 4, 5, 3, open dot, greater. And there's our one-step inequalities.